Assalamualaikum warahmatullahi wabarakatuh. So today our group will be present about the data of temperature and chirps per minute. So for our X is temperature and for our Y is chirps per minute. So before I start, I will explain about introduction. So the introduction is numerical analysis. It's referred to the area within mathematics that focus on developing computational approach and algorithm to solve complex mathematical problems. It focuses on approximating solution of equations, system of equations, and differential equations using numerical methods. The numerical analysis uses techniques such as interpolation, numerical integration, and optimization to find practical and efficient solutions to real-world problems that have no analytical solutions. Numerical methods is referred to the application of computational techniques and algorithms to estimate solution of difficult mathematical problems that are not easily solvable by analytic means. So in our group, we must find a data set containing one independent variable and one dependent variable. We found a data set of temperature and cricket chirps per minute. Using the data set, we must apply what we learned in chapter 4. So what we learned in chapter 4 is the method of least square. To plot the scatter plot with a least square line, a least square quadratic curve, and an alternative function with which we choose natural logarithm, which means ln. Next, we make calculation and plot all the curve. At the end of our project, we must determine accuracy of all the approximations using the sum square error, which is SSE. So what our goal is now to this research is to determine the best fit line that suits our data set. The best fit line will be defined as the line giving the smallest possible total error. Therefore, using the SSE, we will find the best fit line in our data set. Okay, so for the question 1, this is our data. Represent the data number of chirps in minute, which is chirps rate R, and also record the air ambient temperature, which is T in Fahrenheit for the night. The data will collected between 9:30 AM until 10 PM each night. So here the link for our data. Okay, for the question 2, 1 Roman, a least square line. So we are using linear function to be fit. Is fx equal to a0 to plus a1x. So we are using a normal equation in matrix form 2 by 2. So what we get is total number of points n equal to 10. So here is our table to find x, y, x square, and x times y. So summation for x is 705, summation for y is 1253, and summation for x square is 50005, and for x times y is 89698. So after we are using this matrix. So here the matrix, and to solve for a0 and a1, which is we are apply Cramer's rule. So after we are using a Cramer's rule, we will get a0 is negative 580825 over 3025, and we will get the answer is negative 192.0083. And for a1 we will get 4.5008. So the linear function is fx equal to negative 192.0083 plus 4.5008x. So here is our graph. that for the axis x is temperature and for the axis y is cricket shots per minute. So here our graph, which is y equal to negative 192 0.0083 and plus 4.500 ax. This is our equation. Okay.
Next, for the second question, our construct and plot least square quadratic curve. The equation for linear function is fx equal to a0 plus a1x plus a2x power of 2. The normal equation to find this least square is by 3 by 3 matrix as be shown in the slide. To find each value in the matrix, we use Excel by keying in the data first that we found. Hence, we need to key in the data in the Excel to find the value of I, summation of x, y, x power of 2, xy, x power of 3, x power of 4, and x power of 2y. Next, we apply Cramer's rule to find a0, a1, and a2. To find them, we need to find determinant a, determinant a0, determinant a1, and determinant a2 first. As be shown, this is the result after we substitute the value in the Cramer's rule. The results are determinant A is equal 18242040, a0 144296580, a1 negative 5974530, and determinant A2 1010860. Next, we need to find the value of a0, a1, and a2. To find the value of a0 is determinant a0 divided by determinant a, which is the value that we get is 79.1011. Meanwhile, for a1 is a1, determinant a1 divided by determinant a, which is we get the value is negative 3.2751. And lastly, for value of a2, we need to divide determinant a2 with determinant a, which is we get the value is 0.0554. So the quadratic function is fx equal to 79.1011 minus 3.2751x plus 0.0554 x power of 2. Next, this is a best fit curve for line for quadratic function. The x-axis is temperature, meanwhile y-axis is trips per minute. The plots are close to each other but also a bit far apart, which is exact but not accurate.
Next is alternative function. We use transcendental function. Transcendental function is an analytic function that does not satisfy a polynomial equation, in contrast to an algebraic function. In other words, a transcendental function transcends algebra in that it cannot be expressed algebraically. Based on our data, we need to determine the respective value of for n, summation of x, summation of y, summation of x squared, summation of xy, and summation of ln y. From here, we can get n is equal to 10, summation of x is equal to 705, summation of y is equal to 1250. Summation of x squared is equal to 5005. Summation of xy is equal to 3402.505. And summation of non-y is equal to 48.1043. And that is y equal to a power of x, y equal to ln a plus x ln b. Get a equal to a0 plus a1x, y equal to y, a0 naught equal to ln A1 equal to ln B. The normal equation for this step is 4 multiplied by 2 multiplied 2, and our n is 10, and summation of x is 705, summation of x squared is 3005. We get summation of y is 48.1045, and summation xy is 3402.51. By using equation method, a naught equal to 2.2135 and A1 equal to 0.0368. So y equal to 0.0368 x plus 2.2135. A naught equal to ln A equal to exponential of A naught. A equal to exponential power of 2.2135. So we get A is 9.1477, and B we get power of A1 equal to exponential power of 0.0368, and we get B is 1.0375, and the equation of Y is 9.1477 multiplied by 1.03775, the power of x. So this is the best fit transcendental function for the equation y equal to 0.0368 x plus 2.2147.
So we will continue for question 3, which is SSE of linear function. Okay, so here is a table. Well, so for a table we will we okay, this is our question 3, which is SSE of linear function. So here is our table, which is we will find x, y, y prime equal to our equation 4.5008x minus 192.01. So to find the error, which is y prime minus y, modulus y prime minus y, and for the error e square. So for the x here and y, after that we will after that we after that we will put the number of x to the equation, and we will get this. And after that, after we get all of y prime, we must to find e, which is y prime minus y. And after we get the answer, we will do the answer square. So after all, we will get the answer to sum square error of linear function is 46.2249.
To find SSE, which is sum square error, we need to find the new value of y first. The new value if y can be found by substitute the value of x into the linear quadratic function that we get earlier. Next, we need to find absolute error by new value of y minus y. And last, we can find SSE by total or the e power of 2. We calculate all the data by Excel, and the summation of SSE we get is 27.7516.
Next is sum square error of transcendental function. So For the sum square error of transcendental function, we get y new equal to 1.0375 of x plus 9.1477. After we substitute the value of x in the equation, we get the value of absolute error. Then we power the absolute error with the power of 2. So the sum square error of transcendental function is 22171.9541.
Based on our calculations, it has been determined that the quadratic function outperforms both the linear function and the transcendental function with the lowest sum square error of 27.7516. In comparison, the sum square error for the linear function is 46.2249, while the transcendental function has much higher sum square error of 22171.9541. In summary, the dataset consisting of temperature and cricket chirps per minute can be analyzed using a quadratic function through the least square method. Based on our findings, it can be inferred that out of the three approaches considered linear function, quadratic function, and transcendental function, the quadratic function yields the most accurate results. This conclusion is drawn from the fact that the quadratic function exhibits the smallest sum of square error.